In this video, we are going to talk about electronegativity. At the end of the lesson, you should be able to define electronegativity and also explain the variation in electronegativity of elements. What is the definition of electronegativity? Electronegativity is a relative ability of a bonded atom to attract the shared electron. Look at the example by using hydrogen molecule. They share electrons equally to form hydrogen molecule. Both hydrogen atoms are identical. Therefore, it will form non-polar covalent bond. For the second example, hydrogen fluoride. Fluorine is more electronegative than hydrogen. Electron density around the fluorine atom higher than hydrogen atom. Due to the different ability to attract electrons, so hydrogen fluoride molecule form polar covalent bond. Let me discuss the trend of electronegativity across the period or down a group. Okay, look at the figure. When going down a group, electronegativity decreases because the atom has low ability to attract an electron. When across the period, electronegativity increases because the atom have high ability to attract electrons to itself in bond. How to explain the trend of electronegativity? As we going down the group, number of shell increases, so shielding effect increases. The attraction between valence electrons and nucleus occur as atomic size increases. Ability of an atom to attract the shared electron decreases. Thus, electronegativity decreases. When across a period, proton number increases, so effective nuclear charge, that EFF, increases. It will cause attraction between valence electron and nucleus stronger. As atomic size decreases, the ability of an atom to attract the shared electrons increases. Thus, electronegativity increases. Next, I will explain the acid-base character of oxides of elements in period 3. Character of oxide of element in period 3. Sodium and magnesium oxide will form basic oxide. Aluminum oxide will form amphoteric oxide, which it can act as an acid and base. Silicon, phosphorus, sulfur, and chlorine will form acidic oxide. The first three compounds will form ionic compound, and for silicon, phosphorus, sulfur, and chlorine will form covalent molecular compound. Okay, now we look at the equation, the formation of oxide. element react with oxygen to produce oxide. For element in period 3, sodium react with oxygen to form sodium oxide. Magnesium react with oxygen to form magnesium oxide. Aluminium react with oxygen to form aluminium oxide. Silicon react with oxygen to form silicon dioxide. Phosphorus react with oxygen to form phosphorus pentoxide. Sulfur react with oxygen to form sulfur dioxide. Sulfur dioxide react with oxygen to produce sulfur trioxide. And the last one, chlorine, react with oxygen to form dichlorine hexoxide. First, we discuss about basic oxide. Basic oxide form when sodium or magnesium react with oxygen. The type of compound that they will form is an ionic compound. Sodium oxide react with water to form base sodium hydroxide. Refer to the equation. Sodium oxide react with water to form sodium hydroxide solution. But for magnesium oxide is insoluble in water. However, it does react with acid to produce salt and water. By using equation, magnesium oxide react with hydrochloric acid to produce salt and water. Next, for amphoteric oxide. Amphoteric oxide can act as acid and base. Amphoteric oxide form when aluminium react with oxygen. Aluminum oxide is insoluble in water. To show the aluminum oxide as acid, we can using the equation aluminum oxide react with sodium hydroxide to produce sodium aluminium salt. Okay, for the aluminum oxide act as a base, we can using the reaction aluminum oxide react with hydrochloric acid to produce aluminium trichloride and water. The last character is acidic oxide. Form when silicon react with oxygen. Type of molecule is an ionic compound. Silicon oxide is insoluble in water. However, it does react with base to produce salt and water. By using equation, we can see that silicon oxide react with base sodium hydroxide to produce sodium silicate solution in water. For the phosphorus, sulfur and chlorine, the compound are covalent compound. This oxide react with water to produce acidic solution. For the sulfur trioxide, react with water to produce sulfuric acid. Phosphorus pentoxide react with water to produce phosphoric acid. And the third one, chlorine heptoxide react with water to produce perchloric acid. This table summarizes acid-base properties of oxide of element in period 3. As we across the period 3, we can see that trend of acidity increases. That's all for chapter 3. Thank you.